Recitation problem 2. The drawing shows a collision between two pucks on an air hockey table. Puck A has a mass of 0.025 kilograms and it's moving along the x-axis with a velocity of 5.5 meters per second. It makes a collision with puck B, which has a mass of 0.05 kilograms, and it is initially at rest. The collision is not head-on. After the collision, the pucks fly apart with the angle shown in the drawing. Find the final speeds for puck A and puck B. Since the net force at the moment of collision is zero, the only forces involved are the internal forces between the pucks. Therefore, the momentum initial needs to equal the momentum after. P initial equals momentum after. Two items involved in the collision. I'm going to use 1 for A and 2 for B for simplicity. So M1 V1, that's puck A, plus M2 V2, that's for puck B before the collision. Afterwards, M1 V1 final plus M2 V2 final. Notice that the V1 is lined up with the X, which is going to be this, and M2 V2 is 0 because it is at rest, but the V1 final and the V2 final needs to be broken into components. Let me show you how to do the components here. Alright, here are the components for V1 final and V2 final. I'm only showing the Y components. You'll be able to understand what the X components are. For instance, the Y component for V1 final is V1 final sine 65 positive because it's pointing straight up. Automatically the X component has to be V1 final cosine. The same thing can be said about the V2 final. However, V2 final along the Y direction is negative because it's pointing down. The X component is going to be V2 final cosine 37 positive. Now I'm ready to break this equation into components. Let's start with the X component first. M1V1 has a positive M1V1. That's the puck A moving towards the right. Puck B is at rest. Here's the 0. Equals M1 V1 final, like we said a few minutes ago, it is V1 final cosine 65, it's this part here, plus the M2 also positive V2 final cosine 37. However, the Y component is a little bit easier. Why? There is 0 component for M1V1. There is 0 for M2V2 because it's not moving. M1V1 final is the one that is pointing straight up positive. M1V1 final sine 65. Notice here that the M2V2 final is pointing negative. M2V2 final sine 37. At this point in time, I think you're better off substituting for the known quantities, M1, M2, and the cosines and sines. That will make the equation a lot easier to solve. A simple trick that can handle the masses. Notice that M2 is equal 0.05, whereas mass 1 equals 0.25. It's 2 to 1. Mass 2 is twice as much mass 1. In that case, what you could do is you can substitute the M2 by 2 and M1 by 1. That's going to simplify the equation dramatically. As a result, you get X here is going to be 1 times 5.5 equals M1, as I said, is going to be 1. V1 final is not known. Cosine, I'm going to continue working with the cosine. M2 is 2, right? V2 final cosine 37. Alright, let's do the same thing for the other equation. 0 on the left hand side equals, this is 1, this is 2, so it's going to be v1 final sine 65 minus 2 times v2 final sine 37. Look at the second equation here. This one. That's an easier equation compared to the first one. What you need to do, evaluate v1 final function of v2 final. After you move things around, you'll get 2v2 final sine 37 equals v1 final sine 65. Divide both sides by 2 sine 37, you will get the following. Sine 65 divided by 2 times sine 37. Use your calculator and find a simpler relationship now. v2 final is going to equal 0.75 v1 final. This is the first relationship. All you need to do now is you take it as is and plug it into your x equation. My x equation, here we go, 5.5 equals v1 final times cosine 65. Let me evaluate the cosine 65. Times 0.42, that's the cosine of 65, plus v2 final times 2 cosine 37. Let's find that one too. That's 1.60. Alright, now all I'm going to do is I'm going to substitute the v2 final by 0.75 v1 final right here. Right here. Alright, look, it's going to be x is 5.5 equals, bring the 0.42 to the front, v1 final plus, instead of v2 final I'm going to put 0.75 v1 final times the 1.6. Alright, let's evaluate this one and solve for the v1 final. You're going to get 5.5 equals 0.42 v1 final. This one is going to be 1.2 v1 final. When you add these two together, you get 5.5 equals 1.62 v1 final. Solving for v1 final, we will get v1 final equals 3.4 meters per second. To solve for the v2 final, go back to this framed equation right here. 0.75 times 3.4, you would be able to solve for the v2 final, and the answer is v2 final is equal to 2.6 meters per second. And that's it.